or in that link I sent. All right, so here we go. So we're doing our factoring review. Okay, like I said, these are things that you should have seen in 8th grade or in Algebra 1 specifically. Greatest common factor, difference of two squares, and factoring quadratics A = 1. All right, so we're going to look at those 3 ideas very quickly, just to make sure we remember how to do those things. And if you have any questions as we're going along, like I said, put it in the chat on the side. All right. All right. So the first one we're going to look at is difference of, greatest common factor. Remember, that's the most that some things, 2 expressions or multiple expressions or terms within an expression have in common, right? So the first one we have over here is 15x to the 4th plus 3x to the 5th, right? So remember, numbers have greatest common factors. That's something you may have learned like maybe back in like 6th grade or even earlier. Numbers can have a greatest common factors and variables can have a greatest common factor. We just write it as one common term, all right? So the first thing we have to find is the GCF of these 2 terms in order to factor out the GCF, okay? All right, so both of those, the numbers, okay, so I see in the chat you said the numbers both are divisible by 3. That's their greatest common factor. So 15 and 3 have a GCF of 3. That is true. All right, so we know the GCF of these numbers is going to be 3. All right, everybody good there? All right, so now we're going to look at the variables. We have an x to the 4th and we have an x to the 5th, right? So you got 4 x's and you have 5 x's. So we need to determine how many x's do those 2 separate entities have in common to use as a GCF of the variables. So I have 4 x's here and 5 x's there. Anybody remember how you determine the GCF of variables? If not, it's okay. If you don't. If you do, great. All right, okay, that's okay. All right, GCF of variables, y'all, is very simple. All you have to do, you pick the one that has the smallest exponent on it. That's the GCF for the variables. So like you have x to the 4th and x to the 5th. Well, this one has 4 x's, this one has 5 x's. So the most they have in common is 4 x's. So the GCF of the variables is x to the 4th. That's real. You know what I mean. X to the 4th. All right. So when you're doing the GCF of variables, you look at the variable with the smallest exponent. That's going to be the GCF of the variables. Okay. So we found the GCF of this term, this expression. I'm sorry. We found the GCF of the expression. So now we need to actually factor it out. Does anybody remember how you factor out a GCF once you find it? Anybody remember how to do that? Factoring out the GCF once you find the okay, that's fair. All right. So factoring out the GCF once you find it. So we know our GCF on this one is 3x to the 4th. So that means I'm factoring it out. So I'm going to take my expression that 15x to the 4th plus 3x to the 5th. I divide it out by my GCF. So I'm going to divide that expression by 3x to the 4th, each term in that expression by 3x to the 4th. Okay. So then I just divide like I normally would. 15 divided by 3 is 5. X to the 4th, x to the 4th are going to cancel each other out. So I don't have any x's there. Okay. I got my plus sign. 3 divided by 3 divides out to 1. Then I have x to the 5th divided by x to the 4th. Remember exponent rules. When you divide, you subtract exponents. So I got 5 minus 4. So that's going to leave me with 1x. So we just divided through by the GCF here. Each term in the expression, we just divided through and we were left with this. But remember, whenever you're factoring, you just don't leave this. The GCF has to be a part of the expression. So whatever I divided by that's left here, I put the GCF out in front. Oops. 3x to the 4th. Because you should always be able to go back and check yourself to verify your answer by using the distributive property. Okay, so I have 3x to the 4 parentheses 5 plus x. Anybody kind of remember doing something like this last year? Okay, okay. All right. Okay. All right. So GCF, take it out, put it in front of the parentheses, and you get our answer, okay? So we're going to do another one. This one here, we got 16x squared minus 24. Okay. So we need to get a GCF of our numbers and a GCF of the letters. So I know I got 16 and 24. So those are our numbers. And we're saying, what is the greatest number that they have in common? What's the greatest factor that they have in common? Anybody got an answer? All right. I got 8. Anybody else got anything besides 8? Excuse me. Okay, so 8. Okay. So yeah, 16 and 24 both have 8 in common, all right? That is true. So I know I'm going to have an 8. Oops, why did that do that? All right. So I know I got an 8 in common there. All right. Then I have an x squared here. Do we have any variables over here with 24? No. There are no variables over there with 24. So the GCF of this expression is just going to be 8. Okay. So we're going to take our original expression of 16x squared minus 24. And we're going to divide it by 8. So we're going to divide each term in our expression by 8. So 16 divided by 8, we know it's going to be 2. I'm not doing anything to the x squared because my GCF doesn't have a variable in it. So I got 2x squared. Okay. Have my minus sign. 24 divided by 8 is going to be 3. And remember, you're not done because you have to put that GCF in front of the expression with parentheses. Okay. Yes. Okay, so 8 is the GCF, all right? Any questions on any part of that problem? And if you don't want to talk, you can just put it in the chat if you don't have a question. If you have a question, I'm sorry. Any questions on that one? Okay, so since no questions there, last one for GCF, you got 18x to the 4th, y to the 7th, plus 36x cubed, y to the 6th, minus 42x to the 5th, y to the 5th, right? So this one we have 3 terms this time, but we still handle it the same way. We look at our numbers and we see, okay, you got 18, 36, and 42. What is the greatest number they have in common? And then you do look at your variables. You look at all the x's, you look at all the y's, all right? So you got 18, 36, and 42. Those 3 numbers. What would be the GCF of 18, 36, and 42? Okay, I got 1 answer. Okay, I got 2 answers, 3 answers. Okay, good, good, ladies. All right, so that is true. They all have a 6. You can divide them all by 6. They all have a factor of at least 6, okay? So 6 is the greatest common factor of the numbers. Ooh, that's an ugly 6. So 6 is the greatest common factor of the numbers. Oh my. Okay. All right. So then we look at our variables. And so we have an x and a y. So you look at the x's independently and you look at the y's independently. So remember, for variables, you look at the variable that has the smallest exponent to get the GCF for your variables. Okay. So what would be the GCF for the x's and what would be the GCF for the y's? You look at the variable with the smallest exponent. So what's the smallest variable? I mean, smallest exponent on x, and what's the smallest exponent on y? Okay. Okay. All right. Everybody understand what I'm saying when I'm saying looking at the smallest exponent? I see some answers over here in the chat. I just want to make sure you understand what I'm talking about when I say the one with the smallest exponent. Can I get a yes and or a no? I see some people have been, the same people kind of been answering, so I kind of need to know. Okay, okay, yes. So our smallest exponent for x is x to the third, and the smallest for the y is y to the fifth. So our GCF is going to be 6 x to the third, y to the fifth. So that's what we're going to divide the expression by. So the entire expression part is going to be divided by that. So we're going to divide by 6x to the third, y to the fifth. And I'm just going to take this a piece at a time because this is a longer expression. So 18 divided by 6 is 3. X to the fourth, x to the third. Remember, exponent rules, you subtract them. So 4 minus 3 is 1. So I have 1x left. Y to the seventh, y to the fifth. I subtract 7 and 5. I get 2. Okay. So that's that part of the expression. Then the middle part, same thing, divide by 6, x to the third, y to the fifth for that part of the expression. So 36 divided by 6 is 6. X to the third is going to cancel out. Y to the 6th, y to the 5th. I subtract those two exponents. I'm left with a y. And then lastly, we have the last part of the expression, the minus 42, x to the 5th, y to the 5th. Divide, I don't know why that screen keeps jumping whenever I go to the sides here. Divide there. So 42 divided by 6 is 7. X to the 5th, x to the 3rd is x squared. And then lastly, those y's are going to divide out to my final answer. Put the GCF in front. And then what I had when I divided in parentheses. Okay. So that's 3 really quick questions on GCF factoring. That's going to be one of the first things that they review over really quickly for Algebra 2. Okay. Did I put x squared there? Yeah, it's x squared because x to the 5th, x to the 3rd is x squared when you subtract them. Okay. All right, I see now. Okay, I see it in chat. Okay, you're good. All right, so if there's nothing else about GCF, we're just going to do real quick difference of two squares. That one is usually the fastest one. Difference of squares. Remember, if you have two perfect squares and you have subtractions, you have a difference of squares. All right, and you just look at it and say, what and what gives me these numbers? And that's it. So the quickest way I always tell people is you look and see if you have two terms. If you have two terms, that's the first thing for difference of two squares, right? Then you see if they're perfect squares. Now, sometimes you may have to factor out a GCF first, because when you have your hierarchy of factoring, a GCF is always what you look for first. So you look and see if you have a GCF. And if you don't, then you see if the numbers are perfect squares. If they are, then you just factor like normal for difference of squares. So we're going to look here. We have x squared minus 36. We have two terms. So we're good there. That's the first thing we're going to look for. All right. Then we say, okay, I got x squared minus 36. I have a GCF of 1 here, basically. So that's not really important. Okay. We don't worry about the GCF of 1 right now. Then I'll look at the two terms and I say, okay, are those two terms perfect squares? If the answer is yes, then I can factor a difference of two squares. If not, then I can't factor it using that method, okay? So for here, you got x squared and you have 36. Would those be perfect squares? All right, yes, yes, yes. Sorry, I'm getting remind messages as we're doing this too. So I'm Okay, so yes. All right, so real simple. Once you have the perfect squares, I have this over here to the side as an example, but you don't have to write all this out. I always just do this. I write two sets of parentheses. Different, if you look, they're different, so they have different signs, a plus and a minus sign, and it says parentheses. It does not matter which one goes. It doesn't matter. So I can put the minus first, then the plus, or the plus first, then the minus. And then I'm like, okay, well, what times what is x squared? X and x. So I got an x here and an x here. What times what is 36? That's going to be 6 and 6. And that's my answer. Any questions on that one? Okay. So let's look at the next one then. You got m squared plus 9, all right? So the first thing you look for, do you have two terms? Yes, we have two terms, all right? The second thing we look for is their subtraction. Is there a difference? So this one, we got m squared plus 9, all right? Not minus 9. So because of this plus sign right here, this is not a difference of squares. So this one here, for what you're going to do now, because when you go to algebra 2, you're going to talk about different sets of numbers. But for right now, this would be not factorable, because it's not a difference of two squares. It is just, it's a sum of squares, but you'll talk about that in algebra 2. Does that make sense? Oh, why that one you can't factor using difference of two squares? Okay. All right. Let's look here. We got 3b squared minus 300. All right. So we have two terms. So that's the first thing we need to check off our list, which is good. Okay. Then we need to see, okay, remember, always check and see if you have a GCF. GCF on both of these was 1. All right. We don't worry about 1. But on this one, we do have a GCF because this is a 3 and this is a 300, right? So on this one, we have a GCF of 3. Okay. So I know I can divide both of these by 3 because I have a GCF of 3. So I'm left with b squared minus 100. And I got a 3 on the outside as my GCF. But remember, whenever we factor, we want to factor completely. So just because I took out a GCF doesn't necessarily mean that I'm done with the problem. So now I'm going to look inside this set of parentheses. I have a b squared minus 100. That's two terms. I got subtraction. I already took out a GCF. Are these two things perfect squares, the b squared and 100? Would those be perfect squares? Yes. Okay, Jay, let's see what you got here. Yes. Yes, yes, yes. So those are both perfect squares. So I got to keep going with the problem. So I'm going to write my two sets of parentheses. Plus or minus, remember that doesn't matter what set of parentheses you put the sign in. All right, so b squared means I have a b and a b. 100 is 10 and 10. And our GCF here was 3. We can't forget it, so I have to put that GCF of 3 in front. Any questions on that one? Okay. All right, last difference of squares. So we have m to the 4th minus 81. So remember, first thing we look for difference of squares is if we have two terms. If we do, then we keep going in the process. We look for a GCF. If the GCF is 1, we don't worry about factoring out a 1. Excuse me. And then now we're going to determine if we have perfect squares here. So we have m to the 4th minus 81. So we have to ask ourselves, is m to the 4th a perfect square and is 81 a perfect square? So what do you think? You can put in the chat box yes or no if you think they're perfect squares. And I'm just erasing to give myself more space. So would those two things be perfect squares? Okay, I got 2 responses right now. Can I get a few more responses, y'all? Would m to the 4th and 81 be a perfect square? All right. Okay, great. Yes, more participation. Yes, yes. All right, so here we go. So y'all are correct. They are perfect squares, right? So it's like, well, I'm going to do my sets of parentheses. So I'm going to have 2 sets, and I got a plus, and I got a minus. M to the 4th is going to be, I saw somebody put in the chat earlier, m squared, because m squared times m squared is m to the 4th. So I have an m squared in both sets of parentheses. Okay, then 81 is going to be 9 and 9. All right. So we factored out those difference of squares there. All right. So now we have to see, can we do anything else to the problem? What do you think? Can I get a yes or a no? Do you think we can do anything else? All right. I got a no. I got a yes with a question mark. I got a yes with like yes with the capital Y. Anybody else? Think we can do anything else to the question, to the problem? And for those who are just joining, and you might have joined a few minutes ago, I'm going over the first unit stuff you have for Algebra 2, because this is what you need to know, especially for that first unit, because it's quadratics revisited, it's factoring, and all these different things that you learned as like your third unit at Algebra 1. Yes, with a capital Y is a yes. Okay. So yes, you can keep going. So if you look at this part right here, we can't factor this. You'll do that when you go to Algebra 2. You'll talk about different set of numbers. But right now, we aren't factoring this. We can factor this right here. You have an m squared minus 9. That's the difference of squares. So I have to keep this part going. So I'm going to write another set of parentheses. I have a plus and minus sign. M squared is m and m. 9 is 3 and 3. And the part that was out front, I just bring that down. So I have m squared plus 9. Okay. So now it is factored completely. And I think I can fit this one back over here. All right. So we got greatest common factor. That's the first thing you always look for. If you have 2 terms, look and see if you have a difference of squares. The last thing we're going to look at is, hopefully this will be the last things you kind of remembered from when you were in Algebra 1. Factoring trinomials when the a value, when the number in front was 1. All right. You may have done it a number of ways. That you may have done it. Some people do slip and slide. Some people do just straight up plug and chug. Some people just see the patterns and so on when you're doing this. So people may have done it different ways. All right. So here we go. Whenever you're factoring trinomials, remember, you're going to have 2 sets of parentheses. We have a trinomial factoring, right? And then, okay, let me see what you just said. Sorry. If you have the number 6481, 2 numbers without variables for a difference of square. If you should have a variable in the problem for a difference of squares at some, if you're doing it. If you could type the problem in, that would help me a little more to see what you're talking about. Okay. If I have an example of it. All right. So the last thing we're gonna do is factoring trinomials. This is one of the last things you should have done towards the quadratics unit as far as factoring. So the first thing I always say when you factor a trinomial is draw 2 sets of parentheses. Okay. And then you have this x squared in here. So x squared means I'm going to have 2 x's. So I have an x and an x. So now I just have to figure out what's going to go in these 2 sets of parentheses. Very, very simple. This is what you do. Remember, you're looking for numbers that when you multiply them together, you get negative 24. So when I multiply, I should get negative 24. And when I add those factors that I get together, they should add together to give me negative 10, or subtract, however you want to think about it. So I'm looking for multiples of negative 24 that when I combine them together, I get negative 10, okay? So if you just have to list out all your factors, that's perfectly fine. That does not matter to me. It's whatever works best for you. So I have that negative 24. And I'm just looking for numbers that when I multiply them, I'm going to get negative 10. So I know negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. I'm just going to write some more of them over here. So I know 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6, right? Those are factors that are going to give me negative 24. So these are all my factors. So this is my factors list. And now from this list of factors, so this is the factors list. So from this list of factors, I need to see which of those are going to give me, when I combine them together, I get negative 10. So from that list of factors, I need to see which one, when I add them together, give me negative 10. So negative 1 plus 24 isn't negative 10. Negative 2 plus 12, oh, that's 10, so we close. So negative 2 plus 12 is 10, but I need negative 10. So I got 2 plus negative 12. If I use this set of factors right here, 2 plus negative 12, does that give you negative 10? Well, yes, it does. So those are the numbers that are going to go in my parentheses, a positive 2 and a negative 12. So I have a positive 2 and a negative 12. And the expression is factored. Okay, yes, I see y'all put in the chat. You are correct. Questions there? All right. So let me erase this here so I got space for this part. Okay, so I'll just write the answer back here. So you have that, okay? So I'm going to go to this one, same principle, same idea. I don't have a GCF different from one, so I don't worry about it. So I'm going to write 2 sets of parentheses. Have a W in both of them because I have a W squared. So now I'm looking for numbers that when I multiply them together, I get negative 40. And when I add those numbers together, I get positive 6. I don't worry about that, the W on the 6 right now. I don't worry about that. So my factors of negative 40. So I got negative 40. So multiply to negative 40. Negative 1 times 40. Negative 2 times 20. Negative 4 times 10. Negative 5 times 8. Right? And then the reverse of that, so 1 times negative 40. 2 times negative 20. 4 times negative 10. And y'all, you don't have to list all the factors out. I'm just doing that for you, just as a review if you forgot, how to do it. But if you know the factors, you can go ahead and just plug them into the parentheses, okay? I keep on rewriting the same thing. So times negative 8. Okay. So you're looking at the list and saying, okay, which of those numbers for negative 40, when I add them together, I'm going to get a positive 6. So negative 4 and 40, of course, that's 39. Negative 2 plus 20, that's not going to work. Negative 4 plus positive 10, that works. So negative 4 plus 10 is going to give me 6. So I'm going to have a minus 4 in parentheses. and a positive 10 in the other parentheses. And that's my answer. Yep. Okay. All right. This is the last example and we're done. All right, so we have m squared minus 7m minus 60. So same principle. GCF here is 1, so I don't worry about the 1. I'm going to go ahead and write the 2 sets of parentheses. M and m, because I have this m squared. Then I do my multiples of negative 60 that are going to add together and give me negative 7. So I write down all our numbers for negative 60. So negative 1 times 60, right? Negative 2 and 30. Negative 3 and 20. Negative 4 and 15. Negative 5 and 12. Negative 6 and 10. It's a 10, not a I don't know what that is. But it's supposed to be a 10. All right, then the reverse. So positive 1 times negative 60 and so on. All right. Like I said, if you don't have to write out the factors, that's perfectly okay. I'm just doing it for us here, just in case you forgot. And when you go to Algebra 2, y'all, they expect you to really know how to do this already, okay? So it should be really quickly for that with the factors. All right, so negative 60. And when you see which of these in the list are gonna, when I add them together, I combine them together, I get negative 7. Well, we know 5 and 12. At some point when you combine them or subtract them, you get 7. We want a negative 7, so it has to be the positive 5 and a negative 12. So 5 plus negative 12. So those are our factors, positive 5 and negative 12, okay? So that is it for this review of factoring. Like I said, this is the first unit you're going to start when you go to Algebra 2 with quadratics. Next time, we're going to do factoring when a is not equal to 1, because you need to learn how to factor by grouping. So next week on Wednesday, we're going to talk about that. But if you don't have any questions, you're good to go. Make sure you put here in the chat so I have that for you. And also make sure that you get that USA test prep. It's only